us. And so if we use the mixed effects GLM map, you get a map like this, and we get the standard, the insula, and that looks like some thalamus activation from all these pain studies. And you'll see that the random effects GLM, so if we just analyze the COPE values, ignoring the standard errors, it's actually not so different. And then compare these, Stauffer's, GLM. So these methods here, of course, look different. Those are the fixed effects methods. So when you neglect the study-to-study variation, you, of course, basically have less variability, and so you're going to get stronger responses. And it's the same story between fixed effects and random effects in groups. And we basically never do fixed effects analyses with a group, because we never would want to neglect subject-to-subject variation. But this is showing you the impact of neglecting study-to-study variation. And this should be the more generalizable result. This is saying over a wide population, well, 21, population of CMAPs of studies, what are the activations that are likely to generalize? This is probably giving us a better idea than these maps here. Just a little self-promotion. This is a poster that Camille did, and I'll be presenting again because she's not here, looking at some of the sensitivities that you to heterogeneity if you use some of these different meta-analysis methods, both using the traditional mixed effects ones and the fixed effects ones. And so that's poster 2653 that I can tell you more about later. And so now just a few closing comments. First one is just the imperative, as has been advertised before. When you do a statistical result, please share your statistic maps. We want to get beyond this world of just having coordinates. So yeah, it's the easiest thing to do. It makes your paper just one extra thing you can do. And the other thing, and as just a habit, put them up when you submit the paper. It's just a good idea. They're there, and then they're there, and no one will know what they are. But then when your paper gets published, they're just ready, and it's ready to be linked to. And so I don't need to say much about this because Tal just talked about this. But yeah, you get this nice rendering. And I'm actually really excited to try the surface rendering because I'm someone who's kind of surface phobic. And so the idea that I can just upload my volume map there and then use those tools is I'm very excited about. And the other thing I do need to advertise and plug is something that Camille and I have worked on for some time, which is the neuroimaging data model. So if you go to NeuroVault, you'll find that when you upload a statistic map, it will take whatever you have, but it encourages you to fill in some other information, like how many subjects did the subject contributed to the statistic map, what were the degrees of freedom, what was the paradigm, some more details. And that's stuff that you should fill in, and that's good. But of course, your data analysis software already knew all that information, and isn't it silly that that's not somehow conveyed? So we've worked on a project called Neuroimaging Data Model, NIDM, which is to represent all that information in a machine-readable format. So it's a little bit hidden, but within SPM, there is a module, there's a way of outputting your results so that instead of seeing results on a page in a graphics window, it gets written out into a .nidm.zip file, and that is a collection of the key images and the key metadata telling somebody, anyone, all the key information about your study. And then you can upload that to NeuroVault, and then a bunch of these fields are going to be filled in for you. So then NeuroVault will know all those details about your analysis. We've developed an exporter for FSL. That's being an FSL, it's from the command line, but the similar thing. You just give an IDM FSL as a command. You give it the group analysis directory. Unfortunately, it doesn't. We have to tell how many subjects are in each group because that's not. You can't divine that necessarily from FSL. And likewise, you'll get an IDM pack, which you can upload to NeuroVault. And again, the incentive there is that it's going to fill in a bunch of the metadata that you would have had to done by hand otherwise. Okay, so I think Camille must talk a lot slower or was going to say a lot more. So ahead of time. So to restate what's been stated many times, we of course would prefer to do image-based meta-analysis to coordinate analysis, but of course you need the data. If you had all this information, ideally you do the standard mixed effects GLM, which is done in the exact same fashion that in the way that you combine subjects into a group analysis. But of course, if we don't have that, the only practical methods that is available is just doing a random effects analysis on the contrast from each study, and that seems to be a decent approximation to the three-level method. And yes, there are few tools for sort of to implement the rich collection of meta-analysis tools that people use outside of imaging, but we've tried to address that with our toolbox. So I'll stop there. Thanks.